faster and easier. Two words important to innovating companies, as well as the engineers that innovate for them. In this video, we look at an electronic device that was originally designed for education. Since then, it has established itself as a solid and useful tool in engineering. This has resulted in simpler, faster product and process innovation. Welcome to Practical Engineering with Arduino. In short, Arduino is an open source, computer-controlled electronics platform. Let's look at that statement a piece at a time. While an Arduino board has its own electronics, it's designed to connect to outboard electronics and electrical devices like motors through pin connectors. An Arduino board has its own microprocessor, computer memory, and at least one connection to an external computer. This connection allows an engineer to write computer code and upload that code to the microprocessor. Then, as long as it's powered, the microprocessor runs that program over and over and over again, responding to inputs, then responding with outputs and computer data. A programmable microprocessor, a standard programming language, electrical connections to outboard electronics. These three things make Arduino a solid and useful platform for a wide range of products and applications across many industries. Finally, being open source means that there is freely available Arduino programming code and electronic schematics downloadable from the internet to study, change, and distribute. This gives an engineer the ability to leverage the electronic and coding expertise of Arduino enthusiasts throughout the world. Arduino allows you to develop products quicker. Its components are easily swapped and adjustable. Its computer code can be modified on a connected computer and quickly uploaded to the Arduino embedded in the end-use product. This allows you to vary inputs or timing or code logic and immediately see results and iterate your designs. An Arduino can also be coded to give you quick and dirty functionality, rather than needing a standalone piece of equipment. With some coding, Arduino also allows you to automate repetitive tasks, like varying the input parameters of a device and logging the results. The low power needed by an Arduino, along with a wide variety of network connectivity options, allows Arduino to log and communicate data from remote and mobile locations. The compiled computer code uploaded to an Arduino runs directly in the microprocessor. It doesn't use an operating system like Windows. This means it doesn't need to split microprocessor time between numerous foreground programs or background processes. Instead, it runs one program over and over again very quickly. This makes Arduino well suited for applications needing fast data acquisition or systems using fast response feedback loops. Arduino's flexibility and convenient connections to outboard electronics make it a great base for prototyping new product ideas. It is especially useful to the lean methodology. It allows you to easily modify your minimum viable product in order to receive fast and frequent customer feedback of your ideas. Once your prototype is complete, Internet information and service providers can show you a reliable path to a production-worthy product. Being open source, schematics for Arduino boards and outboard components are available online to download and modify. This allows you to shrink your microcontroller and other electronics to only those components required for your product. From there, lay out your PCB components, add a locking connector for your outboard connections, and send your layout file to a board manufacturer to make and load. The result is a solid circuit board ready for validation testing. The Arduino platform is also suited for developing products that require embedded controllers and for connecting your product to the Internet of Things. Whether it's one of the 100 embedded controllers inside a vehicle or a medical monitor securely connected to the Internet, Arduino is well equipped to assist your embedded or IoT development. In the testing arena, Arduino can reduce errors by automating test functions quickly and repeatably. A properly programmed Arduino can also provide troubleshooting functionality to help speed repair work. You can also use an Arduino to log data, either storing it in Arduino memory or transmitting it over any of a number of communication protocols. Starting with the Arduinos themselves, there are a wide variety of boards available from a number of manufacturers. These boards vary by number of inputs and outputs, microprocessor speed, and memory. Arduino boards also come in different packaging options for installing in a building, integrating into a machine, embedding into a small device. There are even flexible wearable boards for sewing into a shirt or jacket. In addition to simple inputs like switches and potentiometers, there are also input devices that turn a physical characteristic, like temperature, into a voltage level that can be read and processed by an Arduino. There are devices that measure speed and acceleration, linear distance and rotational position, sound volume and light. There are gyroscopes to monitor three-dimensional orientation, GPS modules for geographical position, and RFID readers to help identify people or products. The Arduino world also offers a number of output devices to display information or control other devices. Available output components include simple visual displays like multi-digit LEDs and audio devices like buzzers and speakers. There are also outputs like relays and motor controllers for controlling large machines or motors. The Arduino community provides many components that allow data communication to and from an Arduino. In addition to short-range protocols like Bluetooth, Wi-Fi, infrared, RFID, long-range communication is also supported with RF and 3G and 4G components. Arduino also supports the communication protocols of specific industries. In the automotive world, both the CAN and LIN bus are supported. In aerospace, it's CAN Aerospace and ARINC 429 protocols. Manufacturers also support mil-spec and medical device protocols like IEEE 11073. First, in its native mode, while Arduino can light individual LEDs or simple multi-character displays, it cannot display to a high-resolution graphical user interface like a computer monitor. Second, the Arduino is designed to run small programs over and over again. These small programs, once they are compiled, typically do not need much memory, somewhere in the few to few hundred kilobyte range. So Arduinos are made with little memory. Depending on the code you write, the available memory must be managed very carefully. And third, unlike your personal computer, an Arduino has no way to load and run multiple programs. In other words, it does not multitask. On the other hand, an Arduino excels at running one program very quickly over and over again. We hope this overview of Arduino helped you see new possibilities for more effective and efficient processes and products. If we can help assist your Arduino or other development efforts, please don't hesitate to contact us through our website at rcoeng.com. Thanks for watching.